Well, students, we have seen the forward pricing model when the underlying asset doesn't include any cost or any income generated from the underlying asset. Now, we will try to generalize it to include these two aspects. Let us start with the case when the underlying asset involves some maintenance cost. So let us assume that the underlying asset involves an additional cost, say rupees C, to maintain it during the forward contract period. Say, for instance, you have made a contract to sell rice to your counterpart, say 100 kgs, and till the maturity time, you have to store this rice, right? So let's say that the storage space cost rupees C. So somehow you have to get it from the person who is going to buy the rice at time T, right? So therefore that should also be included in your pricing model. If you recall, if this extra cost was not there in the last theorem, we have proved that the forward price is given by S of 0 into e to the power of RT in the case of continuous compounding with prevailing interest rate as R per annum. Okay. Now you are including the cost price also, right? The maintenance cost also. Therefore, you will have to make the total as the initial investment, and then that has to be accumulated to find the correct strike price for the contract. So how will you prove this? You just assume that f of 0 comma t is less than s of 0 plus c into e to the power of RT, and then construct a portfolio which is an arbitrage portfolio. How will you do? You can borrow now the money S of 0 plus C with the continuous compounding interest rate R per annum, and then at the same time you buy the underlying asset from the spot market and also issue a short forward contract for the strike price f of 0 comma t. If you recall, the same strategy we have adopted. Only thing is it was S of 0 in our theorem previously. Now it will include the maintenance cost also. Similarly, if the inequality is in the other way around, then you will do a reverse strategy and build a arbitrage portfolio. So since we assume that there is no arbitrage opportunity, so both these cases will contradict and you will be left out only with the equality. So this is the same idea as what we did previously. Let us go to the next case where your underlying asset gives some dividend. For instance, it can be a stock. Okay. Assume that the underlying asset pays a dividend continuously compounding with rate RD. Okay, so this is something which is just for the theoretical sake, we are assuming it. Okay, so it can be also made easily for discrete compounding, and further assume that there is no arbitrage opportunity available in the market, and also shorts are allowed, that is short selling is allowed. Then the fair price is given like this. Now you see you don't have any cost to maintain it, therefore there is no plus C is not there, but you have a dividend which is paid at the rate of RD. Therefore that one has to discount, right? Because that's an income for you. You should not add it to the price, but you should discount it from the price, okay? Because you already got it as an income, right? So that is the main idea. Again, you can see how to prove this. I will just give you the strategy how to prove this and leave it to you to build the portfolio and find its value and prove that the portfolio is arbitrage. Let me give the trading strategy for the case when f is greater than the right hand side. So what you do is the first thing is borrow s of 0 e to the power of minus RDT. Okay, why you are borrowing only this discounted amount? Because the remaining amount you will be getting as a dividend. Whenever you get it as a dividend, you try to buy that in the spot market, and then by e power RDT unit. It's not full unit you are buying. It's only a part of that unit you are buying from the spot market. Please note that most of the assets like stocks are not allowed to be traded in fractional units. Okay, although certain other assets, something like mutual funds are maybe possible, but stocks are not possible. But this is just a theoretical consideration to prove this model. That's all. Okay, so it's just a mathematical concept. Such things are not possible in the reality. And then you also issue a short forward contract of 1 unit. So now what you will do is you have borrowed only this much money, not the full money, and you bought only this part of the underlying asset in the spot market. Okay, but you shorted 1 full unit in the forward contract. So on the expiry, that is on time T, you have to supply 1 unit of the asset, right? So before this time T, you have to somehow buy this remaining unit from the spot market. How will you do that? Well, you will get the dividend. So from the dividend, you will try to obtain the remaining part, and at time T, you make this unit as a full 1 unit. And then you supply it to the forward contract, and thereby you get f of 0 comma t as the price of that unit. Okay, since f of 0 comma t is greater than this, you will see that the portfolio gives a positive return. Okay, so that is the idea. I leave it to you to now write the portfolio pie, and then the value of the portfolio at 0, and write clearly how you are going to exit the portfolio, and write the value of the portfolio at the expiry, and show that this is greater than 0. Precisely, you have to show that this is f of 0 comma t minus s of 0 e power r minus rd into capital T, which will be greater than 0. And here you have to prove that this is 0, and thereby you will get a arbitrage portfolio. Similarly, if this inequality is reversed, like less than, then you have to just try to reverse this strategy and build arbitrage portfolio. I leave it to you to complete this proof. The next case is, instead of giving the dividend in terms of the percentage of the dividend, we give the dividend explicitly, how much money is paid explicitly from the asset to you. Then you just have to discount it, like how in the cost you have added it in terms of dividend, that money has to be discounted. Okay, so that's the only difference. Otherwise the proof, everything goes as it is. You have to carefully choose the price that you are going to borrow or lend in the other case, and then how much unit you will be purchasing or shorting, and the forward contract accordingly you have to plan, and then trade, and then you make a portfolio for that. Okay, again I will leave it to you to complete. If you know one proof, you can similarly build all the other theorems without any problem. Finally, we will try to establish a formula for the value of the forward contract. What is meant by value of the forward contract? Let us first understand it. The value of the forward contract is given by this formula. What is the idea behind that? You have got into a forward contract at time t equal to 0, and its expiry date is something like this, t equal to capital T. Now, for this period, you have the forward price is f of 0 comma capital T, right? This is the forward price. Now you made this contract with your counterpart, and you are waiting for the expiration date. Okay, but parallelly in the market, others are also trading on a similar contract, that is the same asset, underlying asset, and the same expiry, but their time may be something else, right? That's what we have seen. It may be some T. They also make a similar contract, but since the scenarios changed, the people are different, they may have a different forward price, right? So that with respect to you, it is denoted by f of t comma capital T. Now at this time, you see you have a contract which says you will sell the asset at this price, whereas somebody else has the contract in which they also sell the same asset at the same time but with this price, right? Now with respect to their contract, what is your value at time T? So your value is the difference between, if you are a long position, then their price minus your price. Long means you will buy the asset for this price, right? So if this price is less than this price, it means you are going to buy the asset for a lesser price than what others are going to buy. So therefore you are at a profit. Okay, so the value is something like a present value. Why? Because f of t comma t minus f of 0 comma t is the value on the expiration date, right? But the question is, what is its value today? That is why you are looking for a present value formula. So, okay, you discount it with a prevailing interest rate over that period, right? So that is what it says as the value of your forward contract. Well, it is very intuitive as far as our knowledge in the present and future values are concerned, but why should it work in that way in the forward market? It is true for some other asset like risk-free assets, bank fixed deposits and so on. Why should it work in risky assets, and that too in a forward contracts? Well, that needs a proof, and now we know how to prove that, right? We have already seen how to prove such formulas. The same idea. What you do is assume that v of t is less than f of t comma capital T. See, this idea is same, but you have to carefully build the trading strategy, and then thereby your portfolio has to be framed very carefully so that it becomes a arbitrage portfolio. That is the only idea involved in all these theorems. Okay, and we have assumed that the market is not having any arbitrage opportunity, and shorting is allowed with fractional volumes. That also should be there. Okay, even if it is not mentioned explicitly, you can assume such things. Here you construct a portfolio which is a arbitrage portfolio, and again if it is greater than this, then also you will make a arbitrage portfolio. Let me just give you an idea of how to do the portfolio construction for this case, and leave it to you to do it for this case. Again, I will only give you the strategy. Once you know the strategy, then it's just a mathematics, simple arithmetic rather, to show that the portfolio is arbitrage. How you go is, I'm doing it for this less than case. Borrow an amount, whatever is called V of t. Okay, so these are mathematical proof. Okay, don't connect the proofs with reality. So formulas may be used in real life. So take a long in forward. It means take a long position in the forward contract with price f of t, with the forward price f of t, and delivery time of course is capital T at time t, not t equal to 0. Okay, so you are taking see, you look at this, you are taking this position at this time. Okay, therefore you have to pay some money for this. Okay, this is not a realistic forward. You cannot do such things. Okay, it's just a mathematical proof to justify this formula. Okay, go long in forward with forward price this at this time, hence you have to pay V of t. Okay, the value of that formula, it's something like, so you have taken this contract, at this time with strike price as this, and at this time somebody is coming and asking you, boss, you give it to me. Okay, you cannot give it to that person because on this day the market price of the same contract is different, right? So therefore you will demand some money for that. Okay, whatever may be that money, we are trying to prove that that value is going to be this. Okay, so for the proof, whatever may be the value, you will pay that and get that contract. Okay, that is, your friend will pay and get the contract from you, and your friend will borrow money, pay it to you, and get this contract at time small. At times the t equal to 0, one doesn't need to pay as per the rules of forwards. Now what you do, you give this contract to your friend and take a shot in the same forward at time t with forward price f of t comma capital T. Okay, whether you take short or long, you don't need to pay any price for that, because you are taking the contract for this price at time t. You see, time is matching, therefore that comes as free. Okay, here time and this time, they are not matching, that is why it includes a value. These are the plans. Okay, now given that you can build a portfolio, see, you are borrowing this money, okay, and putting it in this and shorting this. Okay, now you can write it. Now how will you close this portfolio? You can find, and then you can find the value of it as well. Now how will you close the portfolio? You first close the long position. Okay, when you close the long position, it means you will pay this money and get the asset, and then come and close the short position. It means you will sell the asset. Once you get the asset here, you will sell that asset here for this price. Okay, you bought for this and you sold for this, and then repay the borrowed money. So that is how you will close the position. When you close this long position, what is your payoff? You are closing at capital T. Okay, so let me call this as F1 and F2. See, you are closing the long position F1 at capital T. Okay, what is its payoff? If you see, the payoff is RF of capital T 0T, right? And that is nothing but, since it's a long position, it is S of T minus F of 0T. It's a long position. And similarly, when you close F2 at T, you will get a payoff from there, that is minus RF of T 0 comma capital. That is nothing but F of, see, your forward price is this one, F of T comma capital T minus S of T. So you add these two. Okay, that is the total payoff you get from your forward trade. Then you go to pay the borrowed money. Therefore, you have to remove that VT, that is the initially you got. So repay the loan. How much you have to pay? You got this much, and it was continuously compounding with rate R. Therefore, you have to pay this money. Okay, so this minus this is what finally you will get. You show that that is a positive number by assuming this inequality. Okay, so that you can easily see, right? And therefore your portfolio is a arbitrage portfolio. So this will not be possible. Now similarly, you take greater than case, and again a similar but reversed strategy you can adopt and prove the same thing. I will leave it to you to complete this proof also. Well, the next derivative that we are going to see is called swaps. A swap is another type of non-contingent derivative contract. It means at the time of issue, there is no price involved in the swap, which has to be paid by either side of the parties. It also means that both the parties have right and obligation to execute the contract. Swap is a particular type of derivative contract where cash flow streams are exchanged through over-the-counter market between the two parties over a series of specified future dates, because you have the cash flow. Therefore, the cash flow has to happen in a series of dates, and these dates are in future. And there are also certain rules involved depending on what kind of swap they are taking, and also what kind of underlying asset which is generating the cash flow. That also matters. Mostly financial institutions and companies use swaps extensively to hedge interest rates and exchange rate risks over a period of time. Some of the popular swaps are interest rate swaps, currency swaps, commodity swaps, and credit default swaps. Out of these four swaps, we will be concentrating only on the interest rate swaps, and we will not touch upon the other things. So interest rate swaps are basically the exchange of cash flow stream due to interest payment in a debt with another cash flow stream in the same currency without exchanging the underlying principal debt amount. A popular type of interest rate swap is called a plain vanilla swap, where one cash flow stream due to interest rate which has a variable interest rate is swapped with the cash flow with fixed interest rate. However, the underlying principal amount is not interchanged, and hence the principal amount is generally called the notional principal. The variable interest rate cash flow is generally called the floating leg, and the cash flow with fixed interest rate is called a fixed leg. Let me try to explain the plain vanilla swap in a little more detail. Let us consider a borrower called borrower A who borrows money from bank B, which offers him a variable interest rate. It means at every interest period, the interest rate varies as per certain rules. For instance, the interest rate may be fixed by the bank V in its own way, or it may be like some reference interest rate in the market. For instance, 10 years government bond yield as traded in the exchange markets, or it can be what is called the London interbank offered rate. It's a very common rate called LIBOR. Often banks charges variable interest rate by taking LIBOR as a reference. So let's assume that the borrower went for bank V with a variable interest rate, but he somehow doesn't like this. For instance, if a company wants to borrow money and put it in the business, they don't want to have a variable interest rate, and that too it's random, because they want their cash flows in their company to be more deterministic as much as possible. So in order to eliminate this randomness and the variation in their cash flow, they try to look for an alternate opportunity where they get a fixed interest rate. So thereby they may go to another institution, say a bank itself, or it can be any other financial institution who offers the borrower A a fixed interest rate. So what happens is there will be a contract between borrower A and bank F, which says that whatever may be the variable interest rate, the bank F will convert the variable interest rate for the borrower A into a fixed interest rate by giving the variation as a separate cash flow to borrower A. So such a swap is called a plain vanilla swap. Let me explain the mechanism behind this plain vanilla swap. So bank V offered a loan to borrower A with a cash flow, say V, which represents the interest payable by borrower A to bank V. The interest cash flow is, say, 0. That is, on the day he borrowed, there is no interest given to him. This is only the cash flow for the interest payable by borrower A. Okay. So therefore, on the day he borrows, there is no interest paid. But after, say, end of the first period, say 1 year, for instance, or semi-annual, the borrower has to pay the interest, but the interest now is, say, V1. Okay, since it's a cash given by borrower A to bank V, and we are writing this cash flow from the borrower A's point of view, therefore there is a minus sign. And at the end of the second interest period, he has to pay something else, and so on. Till the end of the borrowing period, he will pay. Each VI is different from each other. It may be given as the interest rate, or I into, say, Pn, where Pn is the borrowed amount. So the time period is, say, T0, which is equal to 0, then T1, T2, and so on up to Tn. And the payment is at every time Ti. And these Ri are often random in the sense that they are fixed by the market. So what bank V will do is, at T is equal to T I minus 1, bank V will set the interest rate RK as the bank V will set the interest rate RK as the market interest rate at T is equal to TK minus 1, or it can be the LIBOR at T equal to TK minus 1. Okay, it means the bank will tell at T equal to Tk minus 1 what is the interest rate that it will charge for the interest payment at T equal to Tk. So the borrower A will know what is the interest that he is going to pay for this period. Okay, so up to here only he will have the uncertainty of what is the interest rate for this period, but he will know at Tk minus 1 what is it. But it varies from period to period. So if the borrower doesn't like this varying interest rate, what he can do is he can look for some other financial institution. For instance, let's take that institution as Bank F. He can establish a swap contract where the Bank F will agree for a cash flow to the borrower A as, which is denoted by S, which is 0, that is, at the time of the borrowing, there is no cash exchanged between Bank F and borrower A, but at the first time, that is T equal to T1, the bank will give V minus some S. Okay, Bank X will fix a value S, and it will give the cash flow to the borrower A like this. At time T1, it is V1 minus S. At time 2, it is V2 minus S, and so on till time N, Vn minus S, where this S is calculated as a fixed interest rate on the notional principal. What is the notional principal here? It is Pn is the notional principal in the swap. Why it is called notional principal? Because it never comes, Pn never comes into swap explicitly. It means the borrower A and the bank F, they never exchange this principal Pn between themselves. Okay, it is only a reference to calculate this S, that's all. Okay, that is why this name notional principal is given to this. But between bank V and borrower A, this Pn is something real, because bank V lends Pn rupees to borrower A. So let's take an example. If bank V offers the interest rate like this, suppose borrower A borrowed 100 rupees, that is Pn is 100. Bank V has given borrower A like this. Strictly speaking, this is not known at T equal to 0. Let us just imagine that it is. Bank V is giving this cash flow to him. Then Bank F will give on the day of borrowing nothing. At T equal to T1, Bank F will give V is 6. See, remember, his cash flow is minus V1. So if it is minus 6, it means V1 is 6. So 6 minus, say, if bank F fixes S is equal to 6, the first component is 0. It means on the at time T equal to 1, bank F doesn't give any money to borrower A, because in the swap he already agreeing for 6%. It means he is fine with 6% fixed for all the periods. Therefore, at the first instant, bank F will not pay any money to him. Borrower A directly goes to bank V and pays at t equal to t1, he pays 6 rupees and comes back. Okay. At t equal to t2, bank V is asking for 7 rupees, right? But he wants only 6 rupees, borrower A. Therefore, bank F will come and gives him 1 rupee. That is V2 now is 7. S is 6. So 7 minus 6 is 1 rupee. So bank F pays borrower A 1 rupee, and borrower A goes and pays that 1 plus his 6 rupees, 7 rupees to bank V and meet his obligation at T is equal to T2. That is his 6 rupees plus bank F's 1 rupee. He will pay. But at time t equal to t3, unfortunately, the reference interest rate, that is one of this, whatever is fixed as a reference by bank V, suppose it fell 2%, then the prevailing interest rate at time t equal to t3 was 5, but his agreement with bank F is 6. Therefore, bank F will take 1 rupee from borrower A. It means borrower A will pay 1 rupee to bank F at t equal to t3, and he will go to bank V at t equal to t3 and pays 5 rupees. Okay, because bank V at t equal to t3 asked only 5 rupees. But his agreement is that he can take 6 rupees constantly at every time period. Therefore, he will pay bank F 1 rupee and bank V 5 rupees, and thereby he will make his obligation 6 rupees. So this is the basic idea of a plain vanilla swap. You can see that finally, with the help of this swap, borrower A's obligation to bank V is a cash flow stream with equal interest amount of S, right? So what is finally the borrower's cash flow stream? What is that? V plus S. That is his cash flow stream, which is 0 initially. Then onwards, it is minus S, the amount S that he fixed with bank F. Okay. So this is the interest amount fixed with bank F, right? Therefore, it goes like this up to minus S. That is n times he will be having this. So finally, this is the cash flow where he will pay V amount to bank V and S to bank F. And totally his cash flow became a constant cash flow, and irrespective to whatever may be the interest rate in V, which is in general random, but his cash flow is deterministic. It is always fixed by S, whereas the risk in the interest rate change was observed by the bank F through this swap contract. That is the idea.